Which has been running for a while now to develop this portal in flood and drought management. And this is being done in cooperation with UNEP and other organizations. The background being that often you don't have very good coverage of your ground stations. Data are generally collected in different points and not sort of covering the area. Also, if you're working internationally, your river basin, your river is flowing in from another country, getting data from that country is normally not possible at all. There are also some problems with the quality of data and so on. And satellite data is now increasingly an option. It's often available in near real time. You have varying spatial and temporal resolution, but again also improving. It's often free, so you don't have to pay for it, and you don't have even to do much to just register somewhere and then you can pull it down. There could be some constraints on the format, and accessibility and quality, of course, is a concern, but generally quite a promising source of information. So the objective of this is to provide access to some of this satellite data, mainly what is available in near real time. Collect that to support, but not to replace national data, and in this way have a better common database, you can say. Also to some extent, but outside this project, to bias correct the satellite data. And when this is outside the project, it means it hasn't happened, right? So whatever is on the portal is raw. Sorry. So you may need to check that. So what type of data is there? Well, on climate, there is historical data as well as the near real time. So lots of rainfall, for example, ranging back as far as we can go. Also some forecasts and projections of temperature and rainfall and so on. There's data on the vegetation, on crop distribution and crop growth, both historically and near real time. Data on the soil moisture, and all these generally based on the satellite data, some also here on models, weather models that forecast the conditions. Then there's some socioeconomic data included. If you're working with an area, then you have fast access to that kind of data. And then a range of indicators which are then giving a state of environmental issues, and typical statistical measures which provide an indicator of a state. These are then generally based on all the satellite data. So we'll get back to those. On rainfall, there are different options. TRMM and GPM is maybe the most well-known. The one called CHIRPS is, I think, the longest. It's since 1981, where TRMM is 2000 and GPM basically just 2-3 years old. So these vary a bit in their spatial resolution. CHIRPS is 0.05 degrees, so very detailed, but TRMM is 0.25 and GPM 0.1, like that. Quality varying a bit depending on product and so on. On climate forecast, we're downloading some NCEP forecast from, I think this is NASA, but this is a forecast into the future of rainfall, for example. And it's not just one forecast, but there are 21 members of an ensemble. So there's a range of different forecasts indicating, at least to some extent, the uncertainty of these forecasts. Resolution like this, and 3 hourly in the beginning and then 6 hourly afterwards. This has been operating for 10 years. There's a version 2 also now, which is actually forecasting 9 months ahead, and which is also available. Typically, after a few months, it's just statistics, is our impression, that it's not really, I mean, it's not really possible to forecast what happens 6 months, but still they do it, and maybe it slowly will improve. So precipitation and temperature generally. There are climate predictions, regional climate model for each continent with a resolution down to 50 kilometers. So now we're back to climate change, right? And these are providing these change factors. So delta change factors is typically a way that you describe this. Relatively simple. If you have a change factor of 1.2, it means that you will have an increase of 20%. I mean, so it's in maybe precipitation or so on. But this is available, and we can have a look at that also during the exercise here. This has been calculated for 2 periods, so the near future and the bit further end of the century here. Rainfall, temperature, and evaporation. Evapotranspiration directly, there are these 2 sources, NASA, Moses, and the crew. Again in grids with varying quality, you could say. Temperature is there similarly from the same sources. Then there's vegetation. There is an NDVI is an index which is very often used to assess how vegetation is doing. It's a little bit described down here. If the reflection, when you get reflection from healthy vegetation, there are 2 types of reflection, near and red. And it's 50% near and only 8% red, then it's a rather good condition. If you have like 40% near and 30% red, then it's not so good. Right? So, and this is stressed vegetation. So the NDVI is based on these reflection calculations and given an indication of the health and the growth of the vegetation. Soil moisture. Of course, the satellite cannot look beneath the ground. Right? The satellite can only look on the ground surface. But still, this index is there, and it's based then on satellite measurements of the surface soil moisture. I think maybe the upper 10 centimeters or so have an impact on that reflection. But then it's combined with a 2-layer infiltration model to calculate the moisture content. So they're assessing also that, and then based on that, coming up with this soil water index. So we'll look at that. So indicators typically, you take a satellite image like this, and in this case the NDVI. So this is giving directly here over Thailand what is the current conditions of the NDVI index. An interesting thing, this of course varies over the year. If it's the dry season, vegetation doesn't, the health of the vegetation is less than during the rainy season, obviously. But what is interesting is how does that compare to historical values at the same time of year? So you can look at, we look at deviations from that, of anomalies, percentiles, and so on, and have then calculated an indicator which is showing, is this a drought, or maybe even an exceptional drought, or is it rather normal? Right? So by comparing to what would you expect at this time, you can see whether we are in drought conditions or not. So, so both the NDVI directly is available, but also different classifications like that, like NDVI deviations like that, are given in the portal. Yeah, some socioeconomical, child underweight, and other information about the population density and so on is available. Some perspectives are there for different purposes. You can actually use the data if you want as input to models. I think you're modeling Ganges Brahmaputra outside India and will not have any data available. So from here you could choose to download some of the rainfall, maybe the evaporation data and other information, at least as an estimate, and probably the best estimate available of what are conditions there. Put them into a model and then see what happens, calibrate inside India. We are starting to include some models also on the portal, and I think actually there's a version of the NAM there. I haven't looked at it myself. We will not look at that now. The access that you're gaining now will stay. And I asked my colleague yesterday, when will it close? And he says, I don't know. But most likely, I mean, maybe a year still. This project, I think, goes on until the end of 2018. And I don't think we change anything at that time. And after that, I mean, why should we stop it? If for somehow we need to close down the server for other reasons, maybe it happens one day. But yeah, so you can link it also to planning tools and other information like that. So the way it runs is that daily it updates whatever by downloading satellite images, what is there. Very often it'll find there's no new information, because I mean we depend on all these different providers, right? It says QA here, but the actual quality assurance possible is very limited. So in generally you can just it's just pushed on a number cruncher that does calculations, and then it goes on the web server. So this is the way it looks, and I'll just demonstrate. But before that, we had some problems with the password yesterday. So my colleague has fixed it. For those of you who see your login here, your password should be the same as the one you specified. Everybody else, DHI in small letters. So whatever password you gave, this is now the password. But still the same username, right?
Yeah, I shall note down that line. No, note down for everybody, because they will ask you.
So I'll just leave that here. Yeah.
Note down all.
But you can still, if there's an issue, you can still reset it, and that should also work for now.
Login password is what is
If you find yourself here, here we have 6 people who have given these usernames. You should also use the same password as you specified when you registered. Everybody else, it's called DHI. All those that had a problem. If anybody got through yesterday, then that's also fine. But my impression was nobody could use it yesterday. Now you should all be able to, and most of you will be that password. Have you done? You're gone or no? You're still writing?
It's done.
It's done. Okay. Let's have a look at it. Oh yeah. By the way, I have there are 2 exercises again, step by step, which I copied from one of my colleagues. So here is Africa, but you can just do, and they're here on PDF files, which we'll pass around. Maybe copy to other pen drives so you can duplicate it, right? Once you get that. Let's just have a quick look at it. So I'll log in here. You'll see different entries, data and information and others. We'll only use this one called data and information.
It's not connected.
It's not connected, sorry. Yeah. Oh. And now I click data and information. Anyway, it says so also in the exercise. So it'll open up showing the Ganges-Brahmaputra catchment, and over here are then different data and others that you can look at. If I click, for example, on TRMMM, it'll open that, and here is then a time series from 2000 up to the latest value, which is on 15th of January, so that's 3 days ago. So pretty good. And not surprising, it didn't really rain on 15th of January, but if you go back to, here is the 19th of June, here's the 20th, 21st, like that. So the distribution can be seen in here, right? And you can, on something like that, we can take a time series and just put chart, then we get the time variation of rainfall. And if you just do it directly, it's what's called the all focus area, and that means the whole area we're looking at. That is a bit much to look at the rainfall in the entire Ganges-Brahmaputra catchment. So if you click here, you can go down and say sub-area layer, and then it divides, as you can see here, in sub-catchments. Let's zoom in maybe over here near Delhi. So we have the Yamuna River coming down here. If I click on this one, or in the list down here where the names are also given, then we'll only see the data from this area. So if again I click on the plot, we then have the rainfall. And this is now daily rainfall measured from that satellite over all this period of time. You could also have monthly time series if you want. And if I do that again for the sub area, maybe go over here somewhere, and then chart that. Then the monthly rainfall is given, both the rainfall in this particular area, this is Kosi, Sonkushi, but then the mean is also, so the average over the year is shown in red. If we zoom in maybe on a few years here. So these red curves are the same every year, and thereby you can see, do I deviate from the average of that particular month? So here we had a year 2010 where the rainfall was very high in July compared to normal, right? And maybe in other areas you can find where it's very low compared to normal. So like that you can get some idea of how it's varying. So the rainfall, there is a forecast of rainfall. This NDVI, as I mentioned, so a vegetation index, which is like this, and this is the latest, which is now from December, 19th of December last year. And this is how it looks, and if you click on the deviation, then it will compare how does it look on 19th December last year compared to the 19th Decembers in previous years, right? And with another scale now, where green is positive or high numbers, so it's better generally in these areas apparently, and then it's more stressed here compared to normal, right? So like that, indications are there. The exercises will then take you through some of this data, and click here and do that relatively step by step, I believe. So I have some selected here. Up here, if you click select, you can see all the different data available, right? So under TRMM, there are different kind of SPIs and so on, other rainfalls given vegetation, soil moisture. Down here we have on climate change. For these different projections, like the RCP45, for example, you can take the temperature, you could take the potential evaporation and so on. And when you select one, there's also a brief description here on what it actually is, right? I think if you click help, there is further description, further explanation, right? So you can of course select all, but that means that when you're actually working with it, you have a very long list here, right? So normally I put on just the ones I know I would normally need to use, I want to use. We show them as time series, but you can also, maybe if I take the soil moisture here, you can show what's called a column chart. And if I do that for the whole area, this is then showing over time the percentage of the area in different classification, going from here from 10 to 90, and this is now a soil water index percentile. So how does it vary from normal? If it's very low compared to normal, you have the very red colors. If it's high compared to normal, you have the blue colors, right? And we can take maybe a year here that the distribution of these, normal is then in the middle here, was few areas were red, but not so many. Most were normal, and then some were wet here in March and June. Then it rained maybe probably a bit more than normal. So in July, August, these increased, right? And then it fell like that again. So it can be used a bit. So for example, here is a period where even in the monsoon, July, August, the soil water index percentile has a tendency of being very low. So it's much lower than normal. We can see this is 2009. If we go directly to the soil water index and just chart it, yeah, we can see that the values here, now we can also see the average in the red curve, right? We are generally lower than normal, right? Throughout this year, actually, it's lower than it normally is. But like going through the data like that is described on these exercises. So I think we just go to the computer hall and get going.
Sir, one unrelated question.
Yes.
The question is, how can we use the LIDAR technology or LIDAR data for the water resource management or vegetation? Actually, is there any, is it useful or is it reliable?
LIDAR is normally used to make digital models of terrain, right?
Yeah, but there are two types of LIDAR.
Yeah, okay.
Maybe bathymetric gives us the topography.
Yeah. I mean, there are a range of these different sources that in different ways are measuring also vegetation index. Many of these are included here, and generally what we try to do is whatever is available, and if it looks relevant and useful, it's put in here from wherever source in the world. I think many of these LiDAR you have to order specifically to have them flown in your area, so that's something else, which is outside this one. So let's go up there. This young man, he gets a pen drive, and maybe, yeah, so the first thing you do is to copy it to that one and then start distributing.